So, for those that don't know me, I'm Benjamin Strostrup, and I came here to talk about simplicity and consistency, something that I made many times in the history of programming languages. In my first paper of 55 pages that I talk about the first 10 years of C++. Then I wrote another one, 59 pages, also about the simplicity of this language. And the last one for the Hoople 4, that is about 168 pages because it's very simple language. It's so simple that's why I needed to write so many. But anyway, I couldn't do it. Okay, hello everybody. My name is Hernán Wilkinson, and if you want to read a really good paper, I recommend the one that Dan wrote about the evolution of Smalltalk. You will see what simplicity is there. So we all know that programming languages shape the way we think, the way we understand the problems and the solutions that we write. And sometimes to appreciate that, it's good to see how other programming languages make those programmers think. If we only work with Smalltalk, we will be in a bubble, and we will stop appreciating the things that Smalltalk has, I think. Sometimes happens. So a good thing about teaching at the industry is that you can see the same concept but with different languages. And this is a very old example I used to show. Before Java had lambdas, and if you're a C programmer, also it's a very common pattern if you want to select elements of a list to do a for with an if. You iterate on the array, and if it meets the condition, it adds the number to the result. And also the same thing here. So we have now, we are selecting now, here we were selecting the even numbers, and here we are selecting the names that start with P. So in those classes, I usually ask the students, what's the problem to those guys, before Java 1.8 or to C programmers and so on. And they usually say, oh, you're missing a semicolon. And we start talking about it, and they don't see any problem in this code. And of course, we see some design issues here because we are repeating code. And we all know that if we are repeating code, that means that we are missing an object, we're missing an abstraction, and so on. But those guys cannot see that because they don't have the tool to think about how to remove that code, and that tool is are closures or blocks or lambda or however you want to call them. So that's one way of how the programming languages impact on our way of thinking. There are many other things. One of the things I like about Smalltalk is that it has the same syntax for closures and for blocks. They are the same thing. And of course, that they are objects. So in Smalltalk, we all know that this is very normal code. I mean, we have, I don't know, if the arguments are nil, if true is false with this code here. And we can select this code and assign that to a variable, okay? And now we can do an if true with a variable. Those are very normal things for us. Or we can extract this code and put it in a method. What? Oh. I don't know, M1, whatever. Yeah, I want to do it in all the, that was something wrong. I don't know what happened. Weird. Well, anyway, so these kind of things are very common for us. But what happened with other languages, like for example Java? It's the same example, and as we can see here, we have a block of code with that syntax. That, of course, it is not an object. I cannot assign this to an object. I don't know which type that object would be. We cannot do these kind of things. It's not syntactically possible. And the other problem is that with lambdas or closures, whatever you want to call it again, they could have the same syntax, but they don't. And if you want to do the same thing, but using, for example, in this case, an optional, where you can, write something very similar to what we had here in Smalltalk, you have to use another syntax. So this is the way to define a lambda, and it's not exactly the same as here. So how do these things affect the way we think? So I'm going to give an example I usually teach here at the university, and that's the implementation of while using only objects and messages. Something that you can do in Smalltalk, but it's very difficult to see that in other languages. So usually while is implemented this way, where the condition, and here's the thing, the condition has this syntax. It's like an if condition. So we start talking with the students about how to implement this, and we say, okay, let's try to implement this with only objects and messages. So let's say we have A, and well, this doesn't compile because it doesn't follow the rule that objects and messages. So first the receiver, then the message. That's why it's red. It doesn't compile. So how do you fix that? So you have to move things around, to interchange those things. So what they usually do is they write this. Let's say while true. And now this is a block. So I have to use a block in Smalltalk for that. That's easy. Okay. So now we have this. And when we try to implement it, let's say we will return A. When we try to implement this, the thing is that where do I implement it? Because the receiver is true, in this case, it's a Boolean. So what they usually do is they go, I don't know why it says a string there, they go and implement that. And of course what happens is that small integer A is not 3, it is 2. So it didn't do the cycle, the loop. And why is that? That's because they don't realize at the beginning that this should be a block. Because if we want to be consistent, if the syntax on JavaScript or C was consistent, this should be written this way. And because it's not written that way, is that when they have to write the same thing in Smalltalk, they don't realize that it has to be a block. So let's do it. Let's write this as a block. And now let's try to implement this. It's a very nice exercise. So maybe many of you know how to do this. But it's self-value, if true. And here, okay, I'm going to do it. A block value, so I evaluate the block, and then we have to do the other cycle. So what I'm going to do, I'm going to use recursion. Okay. And now it's working. But the problem with this implementation is that it uses recursion. So this is an interesting, problem to think about. And, how can we remove recursion from here? So, and this is another great example of, having integrated the tools with the language. Because what I'm going to do is I'm going to do this in the debugger, and then we are going to simulate that in the code. So if I don't want recursion, I evaluate the condition first, and then I evaluate the block where I increment A, and now instead of sending the message, if I press restart, I'm not adding a new stack, a context in the stack, and I can, now A is 2, so I check the condition, I evaluate the block, and again, instead of sending the message, I press restart, and now this returns false, and that's how I get out of the loop without adding new context. So the thing is, how can we do the same thing by programming? And yeah, for sure you all know, we can come here and see what is the message that this button is sending. Is restart. And in this case, it's sending restart to the debugger, but we're going to send it to the context. Okay? So how can we do this implemented without recursion? That's right. So now it's working without recursion. So those are the kind of things that you cannot do or see in other languages because there is no integration between the language and the tools. There are different VMs or different spaces of execution, etc. This is an example that I've been using this year when we were analyzing mistakes of other programming languages. And this one is about defining variables. And you know that some languages, you don't have to define a variable. The variable is automatically defined the first time you initialize it, the first time you assign something to it. So and the first time you can think, oh, this is simpler, because you don't have to define the variable. So if you don't have to define the variable, you don't have to be worried about not using it anymore, because then you don't have to go and remove the definition and those kind of things. And yeah, it looks better, but you will see how it gets worse. So let's see that in Ruby. So this is Ruby. It's a very simple example. We have temp1, and we use that temp1 in a closure. And so if we run this, you will see the result is going to be 3. Sorry, it's not running what I want. Okay. 3. So it works as expected. Okay. It's binding to a local variable, and everything works fine. Let's see that in Python. Well, Python doesn't have a very good syntax for lambdas, but anyway, let's say it's the same thing. We have the variable here, we are binding it there. If we run this example, the same result, 3. It works as expected. What happened if we define the variable, we assign the variable after using it? Well, what happened in Ruby? Ruby doesn't allow you to do that. It's a compile error. It doesn't compile. Let's see what Python does. Python says, go ahead, no problem. I don't know. Let's go a little bit further. What happens if we change the variable inside the block? So here is temp1 is 1, and assign 10 in the block to temp1, and then I return temp1 plus 2. And here I'm going to print the result of evaluating that lambda or closure or whatever, and also the value of temp1, just to see if this one changed the original temp1, the one defined in the other context. So let's see what does Ruby do, and what it does is this assignment is changing the same variable. So, and here's the trick. What happens if I want temp1 to be a local variable to this closure? So that's when the automatic definition of variable is not enough, and you have to define it by hand. It's a very similar Smalltalk syntax, but by the semicolon. And now this temp1 is a local variable to the closure. Okay? What happened with Python? The same example. We're changing temp1 inside the lambda, and what Python does is exactly the opposite to Ruby. So because we are modifying the variable here, it's creating a new variable, temp1, for this context, and it's not changing the original one. So if you want to have the same behavior as here in Ruby, instead of defining temp1 as local, because that's what Python doing, you have to say that temp1 is non-local. Okay? Okay, and now it has the same behavior. And there is another example. So what happens if the definition of the variable is inside an if? If that if is evaluated, so the variable is initialized and we get the expected value. But what happens if we send false here? So the if is not going to initialize temp1. So what's going to happen is that undefined method, so that's not understand, okay? So temp1 exists as a variable, but was not initialized. That's why temp1 is referenced in nil. What happened with Python? So if we run it with true, it works as expected. With false, compile error. Reference before assignment and blah, 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 okay? So this idea that, look simpler is not that simple when you start using blocks and those kind of things. And defining variables is a good thing when you have blocks. Okay. Another good thing about Smalltalk is, everything is an object. Everything happens when, sending messages, and you can see all the code, and you can change or expand how things work. I'm going to show an example of how to do that with exception handlings. So here, for example, I divide it by 0. That's going to throw an exception, and I handle that exception. But I'm not going, and this in this case is going to return 10. So we're going to debug this. I want to see why it's selecting this handler. And it's selecting this handler because at some point, when it looks for the handler, no, not here. Here. When it's looking for the handler, here it says self exception class, and as you expect, this is going to return error. The class that is looking for is going to handle the exception, and the class implements handles, as an is kind of. If the exception is kind of self, then I have to handle the exception. So we wanted to do this a little bit more powerful, because it's really strange, or at least a little bit limiting, to have conditions for error handling, for exception handling, to be coupled with the types of the exceptions. So we thought, if I want to add something different here, what should I do? And the answer is very simple. The object that I will put here has to answer handles. So that's what we did. And now, for example, you can have a closure as a condition. And let's say we say, I don't know. Yeah. And this is going to work, because block closure implements handles. I don't know. Now it's not going to handle the exception. And we augmented the conditions that you can put here, for example, to say I want to handle error but 0 divide, or I want to handle error but 0 divide and I don't know halt or whatever. So you can write more interesting expressions and conditions for error handling. So that's something impossible in other languages, because that's in the syntax and there is no way for you to change it. And those are the kind of things that you cannot even think in other languages, because it's not even possible to do it. One of the katas that we teach with TDD is the game of life. For sure, you all know the game of life. And one of the problems with the game of life, well, not only the game of life, every example that uses a board, a game that uses a board, I mean, you can see the code here, but it's difficult to see really. I mean, we are not really seeing the board. So Facu did something great the other day, and I stole his example, his idea, and what he did is, why can I not see the board here? If I press a key, I would like to see the board of the game of life, and not just think about in my head the life cells and how big the game of life is and so on. So I would like to click here, and I would like to see the board and see how it evolves, etc. How difficult that could be. So let's do some research. So for example, where can we start searching for things? Facu already showed that there is a class called Smalltalk Editor. And Smalltalk Editor, besides other things, has a rename. What we did in Quiz is that you can do a rename in everywhere you are. For example, I can be here and press Command R, and it will realize that you want to rename that message. But if you have, let's say, a variable, and you press Command R, it will realize that you want to change the name of that variable. So it realizes the type of element that you want to rename based on the AST of the code. So that's very similar to what I want to do. I want to take the AST or where the mouse is and analyze that. And if the receiver of the message is a game of life, and if the message I'm sending is this, so I'm going to evaluate what this is, and I'm going to show it in a morph. That's what I want to do. So the first thing we have to do is to trap the click of the mouse. Okay, and this is the message. You click the mouse, and then when you click the mouse, you have to take the position of the mouse, translate that to the text, and do what the rename does. Let's see how it works. The rename takes the method node and the class of the code that I'm editing and evaluates this block. And if we look at this implementation, we will see that there is a message that says, with parse node including this position, evaluate this block. Okay, and if not, whatever. So I have to do the same thing. I have to take the method node, then look for the node that is below the cursor, and if that works, then I have to check what the node is, etc. So this is basically not that one, but this one. So I take the node and the class, I look for the parse node below the node, the mouse, and now I have the node under the cursor, okay? But now I have to decide if that message send or that node is a message send and blah, 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 blah. So what I'm going to do it live, because I don't want to start looking for messages in the browser and so on. What I'm going to do, come on. I'm going to debug it. So I have the node under the cursor. Yeah, it's so, okay, let's see. What is this? It's a message node. So the first thing I have to verify is that it is a message node. So my condition will be a node under cursor is message node. And I also want to be sure that the receiver is game of life. So how can I get the receiver? Receiver, this is going to return a node, the key, name, okay, let's see, value, key, value. Okay, good enough. And a node under cursor, receiver, key value. So what I'm trying to show is that you don't have to look for the documentation, go to Stack Overflow and those kind of things. When you have the real objects, you can talk to them and start playing with them to do whatever you need to do. So if I continue, excuse me? No, it's already done. I'm not going to do the whole thing. So here it is. It has to be a message. It has to be a literal variable node. It has to be the receiver has to be game of life. The message you're sending has to be this one. And when you get, and that's true, so you're pointing to the thing that you want to see. So what I do is I evaluate the code on the fly. And if there is an error, forget it. There could be a compile error. And if everything works fine, I open this game of life window and with some other stuff. So, for example, here, now if I click, oh, yeah, I forgot to, sorry. This is live programming. There you go. So now if I click here, okay, I have what I saw. But, you know, I would like also to change the board. And if I change the board, I want to change the code. So why not? Mm-hmm. And now I can start writing the code based on the real representation, the graphic representation of it. And I can make it bigger. I can make the board bigger or smaller. And also, I would like to see what happens if it runs. So let's see. Well, this is not a very good example. Let's go to another one. For example, this one. And I can start playing and see how it moves and, you know, those kind of things. So, and these are the kind of things that you can do with Smalltalk very easily, very fast. That's almost impossible with other languages. And I think this is a good example of the connection between the code and, you know, the final execution of the real model. In this case, something that you can even see and play with. So thank you, Facu, for the idea. So, you know, what I showed this because, again, programming languages shape the way you think. They make you think more stuff or less stuff. They make you dream more or less. And this phrase of design principles behind Smalltalk is so real and still so valid today as it was 40 years ago. And I think most of the people don't realize these kind of things. At least not Smalltalkers. They don't see this power. It's very difficult for them to see the power that Smalltalk has as a creative spirit. So yeah, Smalltalk allows us to make our dreams come true. Yeah? But we have to have those dreams. Thank you.
Just a detail. In your first example,
yeah.
The implementation of while true,
yes.
I think maybe you already did that in your class, but you can use that to talk a little bit more about the theory behind this, which is tail recursion.
Yeah.
So you are...
Yeah, we talk about that, yeah. Okay. But I didn't want to do it, not enough time, but yes, we talk about tail recursion.
Because then the example becomes more fruitful.
Exactly, yeah, thank you. Any other question? It was really clear. Thank you.